because oftentimes we'll learn how to design, but maybe we're not too familiar with the economical and efficient designs for reinforced steel concrete structures. How can these be effectively implemented during the design and planning phases?
They all revolve around constructability. If an engineer, no matter where you are in your career, when you're designing and detailing a reinforced concrete structure, there's really three things to keep in mind. Economical formwork, making sure the reinforcing steel will fit in the section, and making sure.
In today's episode, I'm joined by David Fanella, Ph.D., S.E., P.E., and Vice President of Engineering at the Concrete Reinforcing Steel Institute, or C.R.S.I. If you don't know David already, you might recognize his name through some of the resources that he's published. Studying for my PE and SE, I've definitely used his resources to help pass those. And today we're going to be talking about the essential guidelines for designing economical steel reinforced concrete buildings. We'll explore the impact of constructability on projects' success, especially in seismic regions, and discuss how managing tolerances can streamline construction and reduce costs. I know if you're a student or a younger engineer, there's a lot to be learned with concrete constructability, and a lot of that can be mitigated by knowing how to reinforce concrete buildings in an efficient way. And that's what we're going to be talking about. So whether you're looking to optimize your next project or gain some fresh insights into steel reinforced concrete design, this conversation has something for you. I'm your host, Matt Picardal, and this is the Structural Engineering Channel. David, thanks so much for joining us. I know I have a lot of your publications already, studying for the F.SEI and even in my engineering resources as a structural engineer. So can you tell us about your journey into structural engineering and your current role as Vice President of Engineering at the Concrete Reinforcing Steel Institute?
Sure, Matthew. Just wanted to appreciate the opportunity to speak with your audience today. My journey has been pretty diverse, to say the least. I've been very fortunate. I've been able to work in relatively large structural engineering firms, relatively small structural engineering firms, trade associations. I've had the opportunity to teach structural engineering classes at the university level, and I'm so glad that I was able to do all of that because it's helped in so many ways in my current role. At CRSI, I'm responsible for creation of educational materials for structural engineers. So we have a wide variety of design guides, technical notes, webinars. The main goal for all of these is to help engineers be able to design and detail reinforced concrete structures simpler and faster. In addition to that, I oversee our research and development programs that we have. We've got a lot of interesting things, especially in high strength reinforcing steel, that we were able to get into the code that will help with constructability. I also oversee our codes and standards initiative. So I'm a member of AEC, ASCE, Structural Engineering Institute as well. And those activities are so very helpful. I encourage, no matter where you are in your career, to get involved in a committee in one or more of those organizations that you find interesting. You get to work with some great people. You learn so much. You're able to contribute to the overall excellence in the structural engineering field, and it's just been a wonderful experience.
Yeah, that's awesome. What a journey. So broad too, in terms of the industry, and then going into teaching, and then getting into the technical roles, the leadership positions. And yeah, I definitely agree with the AECI and other organizations. I know when I talk to people in the committees, it's never, and even the younger engineers that are just joining into the industries, like it's oftentimes intimidating if they're young because they think, oh, I don't know anything about AECI or concrete, so I'm not good enough for those committees. But what often happens is And you tell me if this is true. Like that's how you become really good at those. You join those committees, and then you'll learn a lot from them, and then you become more of an expert. It's kind of like not the other way around.
I completely agree, Matthew. And what's been so nice is the people are just so welcoming. You know, no matter where you are in your career, they really want you to get involved. They help you. They do so many nice things, and I would certainly encourage, especially our younger audience, to get involved. You'll find out what a great experience it'll be.
And oftentimes too, I found the resources just some of my background. So I went to once I graduated and I got into the industry in building design, there was a lot of questions on, okay, I've learned the theory of concrete structures. How do I apply it? I've never worked on a real building project or this size before. And I've always found myself going into those publications, those additional resources that most of the time the author of, or even CRSI documents, those have been really practical because they do get into those,
Yeah.
here's a building, and this is how you actually do it, how to detail it too. And so I often find myself referring new engineers, new to concrete, to get into those because oftentimes they don't have the time to go through those in school. And these resources are the ones where you can get a really practical guideline. So I definitely recommend those to everybody.
Yeah.
And what, yeah. I was wondering what the, oh, go ahead, David.
No, go ahead.
I was going to ask my next question on
Sure
the
thing.
fundamental guidelines, because oftentimes we'll learn how to design, but maybe we're not too familiar with the economical and efficient designs for reinforced steel concrete structures. How can these be effectively implemented during the design and planning phases?
Yeah, that's a very, very good question. They all revolve around constructability. If an engineer, no matter where you are in your career, when you're designing and detailing a reinforced concrete structure, there's really three things to keep in mind: economical formwork, making sure the reinforcing steel will fit in the section, and making sure the concrete can flow around all the reinforcing bars so there's no segregation, there's no honeycombing, and everything works as planned. Now, those seem simple, but sometimes they're difficult to implement. But if you keep those in the back of your mind, for example, with the economical formwork, when we're in school, we're taught that economy is decreasing the amount of material that you use. And that couldn't be farther from the fact when you're designing a reinforced concrete building. Because the formwork is such a large cost component, 50% or greater, the cost of the structure itself, we need to simplify, repeat, make it repetitive, the formwork. And if that means using a little more concrete or a little more reinforcing steel, that's okay, because it's totally offset by the savings you would incur with the formwork. So keeping the beams the same width over the entire spans, reusing that width as often as possible. You could change the reinforcing on the inside, but if you keep those members constant and the columns themselves, that has a great ripple effect as well in terms of how the reinforcing bars get laid out in the slabs and such. So if you can keep those three in the back of your mind throughout, any project that you go through, you can almost guarantee you're going to have a successful economical project.
For newer engineers, how would they go about maybe learning more about those constructability comments, especially if they're structural engineering design? Most of the time, they're probably in the office. Do you have any tips or guidance or resources that you could recommend that they go out to gain more, to learn more about the constructability issues?
Sure. We have, as I had mentioned at the onset, we have a number of resources that they go to. We have a fairly large design guide on the AEC 318 provisions. And like you had mentioned, Matthew, we take typical buildings and you go through all of the different aspects of it, laying out the framing, laying out the reinforcement, seeing how it all comes together. And working with some of the younger engineers when I was practicing, they know how to design, maybe not detail so much, but their biggest mystery, so to speak, is how does it all fit together? And so there are resources that are out there that can help them. We have a seismic design guide that's also useful. If you're practicing, one of the things that I, really stress is cutting sections, especially where things are not typical. Our drawings always have typical details, and sometimes we rely too much on those. So if you want to, really be successful in terms of avoiding RFIs, avoiding that dreaded call from the contractor that things are not fitting in the field, cut those sections. I know the schedules are tough. I know the fees are tough, but they will save you a lot of headaches in the long run.
Yes, I remember one of the mistakes or mislookings as a design engineer. You cut a column or a beam, and yeah, it shows the reinforcing of all the, let's say, longitudinal reinforcing, but then maybe you forget the splices, and it becomes like really
Yes.
congested, and then you'll get a call from the contractor. Hey,
Yep.
stuff's not fitting. Might be too congested for this one.
Yep. And that's
And
where
for
tolerance.
the
Oh, I'm sorry.
oh
Go
yeah,
ahead.
yeah, I you have to have the tolerances too. It's sometimes they're working with inches a lot of the times, and then yeah, something goes off out in the field. It's like, yeah, it's not fitting or it's too congested.
Exactly.
How does, I know you mentioned some of the constructability that affects structures. How does that take into account, or how does that get influenced by some of the high seismic regions? Like what can, if you make some type of constructability mistakes, how is that made worse in seismic regions, or just in general, like a domino effect of economy?
Yeah. As you know, Matthew, when we have to design for moderate to high seismic areas, the strength, stiffness, and ductility recommendations, not recommendations, I should say, requirements are exponentially increased. So at those particular locations where we expect flexural yielding to occur, the rebar can be very congested. So without looking, like you had mentioned earlier, say at a joint where, you have all the bars from the beam coming in, the column could also be a wall, especially with coupling beams. You could have a lot of rebar. And if you don't cut those sections and you examine exactly what's going on there, you could have a disaster in the field. I've seen it happen before. And unfortunately, these things were not caught until they were actually built. And that can be a tremendous problem in the field.
Yeah, I some of the things also with technology is I've seen some shop drawings where I believe some of the fabricators would actually do 3D models of highly congested areas like coupling beams or beam column joints. And that's helped the team out too in terms of, working as a team. Uh, Things like that, that definitely helps out. And that they can help point out areas that are going to be really congested, and then better really catching it there than going out to
Yes.
the fields.
Yes, absolutely. We've, some of our member companies, the detailers are just outstanding. Now, they're not responsible, as we all know, for the structural engineering of it, but they'll take what you put on your drawings, put it together, and a lot of times in a 3D model, and they'll catch those things exactly as you mentioned.
And what are some of the most common mistakes that you see with in terms of concrete design, inefficiencies, and how can they be avoided?
Yeah, not a couple things. Not putting enough information in your drawings. Again, going back to looking at how the stuff all fits together. Not considering tolerances. We know in a perfect world, there's nothing that's ever going to be built completely plumb, completely horizontal and such. So if you could think about tolerances as you're creating your details, that would also be very helpful and eliminate some of these mistakes. One thing I've always come across is, say you're in the top story of a building and you have your vertical bars from your column and your wall coming up. A lot of people just like to take those longitudinal bars and hook them right into the top slab, which is fine, except when you think about the tolerances on the length of the bar themselves could be plus or minus an inch, tolerance on the thickness of that slab, tolerance on the location of the reinforcing bars in that slab. You could wind up with those bars interfering with the slab bars. So what we recommend, if you think about these details, is stop your longitudinal bars at the underside of the slab and then provide a dowel with a hook at the end that somebody could easily adjust in the field to, circumvent any possible interference in the future when this thing comes together. So thinking about stuff like that, where could you have issues where, instead of setting the bar at this definitive length, how can I adjust it a little bit in the field to make everyone's life easier when it's being constructed and you won't get those RFIs?
Yeah, it might be, if you're thinking about those, it might be technically more steel, but you'll avoid, it's better than getting that call where, hey, these bars are sticking up. We need to cut them. We need to do something because there wasn't that tolerance that engineers might not be thinking of at that time.
Absolutely, Matthew. And those are going to be way more expensive than putting in a little extra reinforcing steel that, the contractor's time is money, obviously, and they don't want to mess around. And when those calls come, you better answer them very quickly.
Yeah. And collaboration is a big thing, especially in today's complex projects. How have you seen, how can engineers, architects, and contractors work together to achieve more cost efficiency in their projects?
Yeah, I would highly recommend, if the concrete contractor is on board when your contract is approved, speak with those people immediately. They are going to help you beyond ways you can even realize with respect to so many different aspects of the project. How are they going to form it out? What's the schedule going to be? Even material availability. I've seen some projects where the engineer has assumed maybe a certain grade of reinforcement throughout the entire design, and then the contractor tells them, well, we're not going to have that available. That's a killer. That's going to eat into your fee, obviously. So, just talking about the different aspects, material availability, how's it all going to come together, different types of formwork, and how can we, especially say in a high seismic zone, it's really, really important to get together with the engineer and the contractor and help lay out the lateral force resisting system. More than, say, if you're doing a building in Chicago, for example. Good architects are going to accept this without a problem. They know what they're doing. You want to avoid any type of vertical or horizontal irregularities because those could be killers in terms of making the lateral force resisting system work in the high seismic zones. Anything like a soft story, things of that nature. Again, the architects who work in these areas know this, and they'll work with you very well. But there's a lot of areas of the country, which Matthew, where seismic is now being introduced for the first time, and there can be that gap in knowledge, and that's where we have to come in and help out, to make sure that the structure is economical.
Yeah, especially with telecommuting, architects and engineers maybe in the East Coast or in the Midwest, they may not know, but they may be working on a project in California or a high seismic zone. And then it is, definitely giving them the go around or the summary of, hey, this is what happens if due to high seismic areas. A lot of those things that you mentioned, transfer beams or irregularities can definitely have a huge cost on the projects. And reflecting on some of my experiences, working when the contractor would get on board early on enough in the project and we'd be discussing lateral systems, it was great when they could guide us through, here's what we're going to be doing in terms of scheduling wise. We're going to lay out the first floor, the second floor. Here's how we're going to form it up. And then it would save us a lot of headache out in the field, especially in terms of their pour sequences.
Yes.
because wherever they're going to pour it, that's going to affect the joints that are going through it. And having all that up and just having those conversations in the beginning, it was comparing those projects where you just do the design, then you get the contractor on board later. It saves so much time and
Yeah.
headache. So being
Yes.
on those teams where you get that collaboration, yeah, it's definitely worth it because you learn so much from the contractor as well on the things that they're going to do it.
Yeah. Absolutely.
And I was kind of curious about since I wanted to ask some career questions, some follow-up ones, since your career was so vast. What did you like and what did you learn? And what were the pros and cons of going into those different disciplines? I know you mentioned you worked at some small and larger firms, then you went into teaching. What were some of the key insights and lessons learned from those?
Well, I was fortunate, at most when I was a younger engineer just starting out to have some great mentors. And, and again, as a advice for our younger audience, try to find that person who's willing to help you and to guide you along because that's so important. I also used to tell our younger engineers, everyone wants to work on that 100-story building, the new structure, because that's the flagship project. But more likely than not, they're not going to be able to work on something like that right away or even ever at the firm that they're at. So I always recommend, it's great to work on the new projects. They're very exciting. But if you can get into an existing building, rehab of an existing building with the structure, that's where it could be really, really exciting. And all of your engineering creativity comes out in those cases because unlike a new building where you have a blank page basically, and you have your architectural layout, you pretty much know how everything's going to go. But if you have to start cutting openings in big transfer beams or removing columns or doing things of that sort, that's where, at least in my opinion, the real fun occurs when you're working in structural engineering. And I always tell them, do 50-50, get in the new projects, get in the existing ones. You're going to be very satisfied with all of those. The teaching aspect, Matthew, I loved it as well. Helping younger folks to understand some of the things that, you've come across and some of your experiences was fulfilling as well.
Yeah, I really resonate with the advice of new building design and existing building design. So for me personally, a lot of my work has been new building design. So yeah, getting to work on all sorts of projects, large, small. And now recently I've been working on existing building projects where we're doing some retrofits, non-ductile concrete structures, etc. And yes, I could definitely see I'm definitely more engaged with at least with the existing building design, because there's no typical details. It's each building's
Right.
unique, and then they want to do something different on whatever you have to do to retrofit or renovate, and it's an engaging. That's where it is. The solutions that you're talking about. Here's the existing
Yeah.
structure. How can we retrofit this to achieve the client's goals and keep the building safe?
Yeah.
And it's always not straightforward. So it's things like that. I've been learning, and it's been really engaging for me just to get that aspect of it in my career, the existing renovations, and learning what the whole processes are, new codes too. It's
Yeah.
been really engaging. So getting both of those, I think that's great advice. I'm actually taking that advice right now. So
Great.
it's been really exciting.
Wonderful.
And did you have any final advice for students or engineers, maybe working engineers too, on how to advance their career?
Oh, sure. For our younger engineers, one thing I always recommend, try to understand the problem before you come up with the solution. Cranking the numbers out with all the software we have now and everything, that I think is the relatively easy part. But what seems to be overlooked sometimes is what are we actually trying to solve? Is it getting the boundary conditions done properly, understanding how the loads go through the structure. If you could spend the majority of the time understanding that, the rest is going to be easy. So that's usually my advice for younger engineers just starting out. This one we touched on earlier, getting involved in some type of association. I was fortunate enough again to be involved with the Structural Engineers Association of Illinois. What a great association to be involved in. I spent 10 years, going through all the different ranks as member all the way up through president. And I can't tell you how rewarding that was. I'm still involved with them. I'm teaching a refresher course for concrete a couple nights a week. And that refresher course is to help people pass the structural engineers part of the licensing exam. For the folks who've been around as long as I have, I always try to learn new stuff. It's always been rewarding, the new codes, the new things that are coming down the pipeline, trying to understand the computer programs and making sure that what comes out of them makes sense. So, I can't stress enough, the constructability aspects of the things. We're actually on the initiative to start a constructability initiative, I should say, here at CRSI. We're partnering with the American Society of Concrete Contractors. We're in the very early stages to come up with a standard and also some typical details that people can use, that knowing that if you apply these to your structure, you shouldn't have any issues with constructability.
Yeah, that's great. Great, awesome advice. And looking forward to that too with the constructability initiative, because I think it always was a challenge for engineers that have never, that have been in the theory. So how to bridge that gap between construction and the engineering aspect. Obviously more site visits helps, but maybe a more formal process like that'd be really cool. Looking forward to that. David, thanks so much for coming on and talking about it and talking about all the resources. It's been great to meet you and talk to you, because for me, it's always like, oh yeah, I've always seen this name on my books. Oh, it's been really great to see and talk to you. I appreciate it.
Well, thank you, Matthew. I completely enjoyed the experience here and look forward to hopefully many years still practicing.
Absolutely. I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.